Hi everyone, I'm Shubham Jhanwar. I'm a master teacher at Vedantu. We are discussing JEE Advanced 2018 Paper-2 Mathematics, and the question for this video is this. Let S be the set of all column matrices B1, B2, B3 such that B1, B2, B3 are all real numbers and the system of equations in real variables minus x plus 2y plus 5z equal to b1, 2x minus 4y plus 3z equal to b2, x minus 2y plus 2z equal to b3 has at least one solution. Then which of the following system or systems in real variables has or have at least one solution for each this column matrix b1, b2, b3 belonging to the set S? So these are the four options. Let's solve it. This is a multiple correct type question. So here basically the column matrices b1, b2, b3 are all such that this system of linear equation has at least one solution. And this set of column matrices is said to be capital S. And what we are looking for is which of these four system of linear equations has at least one solution for all of these column matrices b1, b2, b3. And you can note b1, b2, b3 are being used in all these four options, system of linear equations. So let's explore. So first of all, we'll go by this first set of linear equations, not from the option, but from the question. This set of linear equation we'll consider, and we'll try to explore for what column matrices b1, b2, b3 does this system of linear equations has at least one solution. So the first thing that we'll see is this determinant, which is formed by the which is formed as columns being the coefficients of x, y, and z of these three equations respectively. That is this determinant. Clearly this determinant is 0. Why? Because column 1 and column 2 are proportional. If you multiply every term from column 1 by minus 2, you get the column 2. So that means this system of linear equation doesn't have unique solution. So for it to have at least one solution, it should have infinitely many solutions, which means d1, d2, d3 all should be 0. That is, these determinants should be 0. Now here, clearly this determinant would be 0. Why? Again, because column 1 and column 2 are proportional. Now for these two determinants to be 0 too, you get a unique relationship between b1, b2, b3 as b1 plus 7b2 equal to 13b3. That is, all the set of values of b1, b2, b3 which satisfies this equation belong to set S. Now let's consider the options. Option A, if you consider the determinant D, this determinant, which is basically having coefficients of x, y, and z as its columns, turns out to be 12, which is not 0. So that means no matter what b1, b2, b3 are, this system of linear equation will always have a unique solution. That also means at least one solution. That also means that it will have a unique solution, at least one solution, for all the column matrices b1, b2, b3 belonging to set S. Because no matter what b1, b2, b3 be, this system of linear equation will always have a unique solution. So that means A is correct. Now let's go for, first of all, D option. Here also I'll consider the determinant D, essentially made by the coefficients of x, y, z as its columns. The value of this determinant turns out to be 54. Again, not 0. So again, no matter what b1, b2, b3 are, this system of linear equation will always have a unique solution. That means at least one solution for all column vectors b1, b2, b3 belonging to that set S. Hence, this is also correct. Now let's go for option C. Here these are three equations, and if you see carefully, this is x minus 2y plus 5z equal to minus b1, x minus 2y plus 5z equal to b2 by 2, and this third equation is x minus 2y plus 5z equal to b3. Now these are clearly representing three parallel planes. Now for this system of linear equation to have at least one solution, these parallel planes should all be coincident. That essentially means b1 should be equal to b2 by 2 should be equal to B3. My bad, minus B1. So here, for the system of linear equation to have at least one solution, B1, B2, B3 should follow this condition or these conditions. Now clearly, the system of linear equation would not have at least one solution for all B1, B2, B3 belonging to set S. Why? Because all B1, B2, B3 belonging to set S follow this equation, B1 plus 7B2 equal to 13B3. However, for this system of linear equation to have at least one solution, B1, B2, B3 follow this condition. And this condition is not an equal set or subset of this condition. So that means the condition that we have got for option C would not hold valid for every B1, B2, B3 belonging to set S. Now it may hold true for some column vectors or column matrices B1, B2, B3 belonging to set S, but not all. And what we want is, we want that the system of we want those system of linear equations among the options which have or has at least one solution for each of B1, B2, B3 column matrix belonging to set S. But that's not the case in C option. So that means this is not my answer. For example, you may say if you take B1, B2, B3 to be 0, 0, 0, this condition is satisfied. So is this condition. However, for example, if you take B1 and B2 to be 1, 1 each, and hence B3 will be 8 by 13. So 1, 1, 8 by 13 being B1, B2, B3 respectively. This equation is satisfied. It is part of set S, but this equation is not satisfied. You put B1 to be 1, B2 to be 1, here itself it breaks. Yeah, so C is not my answer. Now going for the option D, option B. So here, first of all, when you consider this determinant D comprising the coefficients of x, y, z, this determinant is clearly 0. Why? Because column 2 and column 3 are proportional. If you multiply every element of column 2 by 3, you get column 3. So that means for this to have at least one solution, D1, D2 and D3 all should be 0. That is, these determinants should be 0. Now here clearly D1 would be 0. Why? Because column 2 and column 3 are proportional. So that means determinant D2 and D3 should be 0. And both of them, when you expand, give you this relationship in B1, B2, B3, B1 plus B2 plus 3B3 equal to 0. Now again, this relationship in B1, B2, B3 is not satisfied by every column matrix B1, B2, B3 belonging to set S. Yeah. For example, if you take B1, B2, B3 to be 0, 0, 0, it satisfies here and it satisfies here also. However, again, if you take B1 and B2 to be 1, 1 and B3 hence would be 8 by 13, 1, 1, 8 by 13, 1, 1, 8 by 13 is not satisfied, doesn't satisfy this equation. So that means, again, this system of linear equation would not have at least one solution for every B1, B2, B3 column matrix belonging to set S. So that means this is also not my answer. So that means my answers are A and D. Thanks for listening. Stay tuned for the next question.